And I done this. Whether it will record or no, I don't know. Okay. Okay, now let us begin here. Now there are four parts as I told you. This is the body, very simple body. This is the body. Okay. I don't know why people are again coming here. Okay, so this is the body, very simple body. Okay. Now let us start this. So what we do is the three things as I told you. Body, um, the body is there. Cutting rod, almost same sort of thing. And piston. Okay. So let us begin here. So what you do? New assembly. Okay. And just give it whatever comes. Let it be. Then design. Let it be. Let all these things. Let it be. But switch off default template. Okay. Then you know. We'll go MMNS dash ASM. This assembly dash design. You have to choose this one. Okay. Now let us bring the first body. So it has to be grounded. First comes the body. Open. So let us ground this. So as I told you, you can either fix it or you can do default. Please remember the first part has to be grounded. So we can go for default, no problem. So I'll also go for default. So just click on this. This is the first part. Okay, so this is grounded. You see it is written fully constrained. The first part is fully constrained. Okay. Now what you have to do is now you have to bring you can bring piston, you can bring any part, doesn't matter. So let us bring the piston here. Again assembly, assemble. Let us bring the piston here. Okay. Okay. So just rotate it a little bit. Okay, I want this to slide here. Okay, the objective is that I want it sliding here. Okay, so what I do is I go for a planar connection. So here user defined. For the previous case I didn't do anything. I just went for default. But here now I have to define the connection. So go to user define, say slider with the slider connect mechanism. So you can go for slider. So what we can any two surface will do. Let's say this surface and the internal surface here. This this surface inside surface. Okay, I can show it here also. Okay, you can show it here, but it's better here only. So let's say this surface and this inside surface, and you can go for either this, then let's say this surface and this surface. These two would do. So go to placement here. Let's say this surface. Sorry, not the edge. Okay, you have to, if something like this comes, you have to delete it. Remove it here only. In assembly, this surface. Assembly component is this. Okay, it's not taking. Let's go for component. Let's go. It has gone for axis alignment. It's not axis alignment. Something like that comes. Let you can just remove it. You can go for a slider. Oh, look, you can go not slider. You go for planar. Because slider is asking for axis. That is also true. You can do slider also. But if you have axis, is better. But I don't have axis. Go for planar. Okay, planar is because I want surfaces here. Okay, flat surfaces here. It's better to go for planar in this case. So assembly item, this, and for component item, this surface. Okay, this is not yet done. Please understand. Okay, see, though it is showing connection definition complete, it is not done. Okay, well, these two are aligned. That means it can be anywhere. So what you do, you have to define one more time. Let's say, then you go for new set. Again, it has taken planar. You can choose. You can change here also. So it is. You say again go for planar. So you say this surface with this back surface. Okay. And now again saying it is complete. Now let us check. If it doesn't happen, then we can again come back and redefine. Go to drag components, click here and click anywhere here. Anywhere. So yeah, it's sliding on this body. So my first component is done. So just keep it anywhere. Close. Now you can bring the connecting rod here. Okay. You can bring the connecting rod and connect it here. Okay. So again, assemble, assembly, go for connecting rod. Open. So where is the connecting rod here? So what you do is you go for pin connection here. Go for pin connection. This is rotating here. This is rotating here. So let us go for pin connection and we switch on the placement. Let us see axis alignment. You switch on the axis here. So when you switch on the axis, you can see all the axes are here. I think all the names are okay. Names are not displaying. I'm switching all the names. So I'll just switch on this so you can see. No, it is so. You can see this axis is here. Okay. So let us coincide here. This axis is coinciding with what is cracking. Okay, I'll go very slow. I think your connection is problem. Okay, connection is problem. Okay, I'll just go slow here. Now, as I told you again, I'll do this again. So next is you can bring the crank also and connect it here. But again, you have redefined that two times. So better you bring the connecting rod here. Assemble, connecting rod part, open. So this will go here. So I'll just move it here. Move it a little bit. Okay. So it doesn't hamper my another connection. So in user defined, as I told you, you go for pin. Okay. In placement, automatically when you do pin connection, it will ask for which axis you are going to align. So I'll say this axis and this axis first. This axis and this axis. Now again, it will ask for translation. In translation, I can give a edge, I can give another plane. So what I do is since these are of almost same size, I'll say this surface and this surface are in translation. So for component item, I can go for this also, this back side. Anything will do. See, if I do this, I can coincide also. I can keep some distance between them also. No problem. So for translation component item, let's say not picking up. This is a component. So I'll say this surface, and for assembly item, let's say this surface. So this definition is complete. Okay. Now, if you see, if you rotate it, you're rotating here. This sliding, this rotating. So let us keep it like this only. See, as I told you, translation you can do you can put some distance between them also. No problem. But in this case, since all the dimensions are same, so let us keep it like that only. See, here what I did is, for translation, I took this surface of the pin on the piston and this surface. These two are coinciding. Okay. If you see here in translation, I can do other way around also. I can remove this. Instead of that, I can do this also in component placement. okay, this surface, and for assembly component I can do this surface also. This will also do. See, you see connection definition complete. This status has to come. Okay, that means the connection is totally complete. Okay, this will also do. If you drag it, you can find out. It's rotating. It's going this side, I know. Okay. No. Now we have to bring the crank. Okay, crank, we have to bring it here. So again, assembly, assemble, crank. Bring the crank here. Open. So if you can see the crank, okay, this has to be here. This it has got a this protrusion is here. That means the hole will go here. So again, what you do, you go for pin connection, placement, axis alignment, this axis, this axis, and this axis. Yeah, a little bit I'll rotate this. Now see, it's not, as I told you, the pin connection, two things has to be defined, that is axis alignment and translation. Again, you can go for these two, but component you can say, okay, this surface for assembly item, this surface. This will do. So if you see, connection definition is complete. But again, see, this has to be connected with different connecting rod also. Okay. So for that, again, we have to have a new set. So you can go pin connection also. Oh, it's simple, since it is already connected, it will not go anywhere. You can go for simpler connection known as cylinder connection. Cylinder connection. So in cylinder connection, same thing. Axis, it will ask for only axis alignment. So you can go for this axis and this axis. So connection is complete. Connection definition is complete. So all our components are now fixed. So if you try to rotate now, let us see. So this is a slider crank mechanism. People, please load Creo in your system and do this. I'll give you the dimensions now. Okay. I don't know whether the screen recording has done finished or no. If it's there, I'll just post this also. If screen recorder works, I'll post this also. Now, please note down the dimensions here. Body. First part is body. Okay, please, everyone, please make a simple sketch of this. All of you, please make a simple sketch of this. Okay, get a pen and paper. Please get a pen and paper. Note down the dimension. So this 120 by 15. This length is 120. This is 15 mm. Please note this. And this protrusion, this is 10 mm. This dia 10 mm, and it is 10 mm from the center is 10 mm from this edge. Center is 10 mm from the edge, and the protrusion thickness of the protrusion is 5 mm. Okay, noted. Okay, these dimensions are enough to create it. Now for the next piston. This piston part, it looks like this. Let's say from the front view. So dimension for this, so this 15 mm, 25 mm. This 15 mm, 25 mm, and how much thick? 20 mm thick. This is 20 mm. This is 15 mm, this is 20 mm, this is 25 mm. So when you create this first extrusion, ensure you create it on the both the sides because you require the surface, you require a plane to create this. Not showing. Now, is any other people having problem with the screen? You are able to see it. So just make a sketch. Okay, please quickly make the sketch of this. Okay, and then I'll tell you the dimensions. This is the piston. Dimension, as I told you, this is 25, this is 15, this is 20. Okay, this height is 25, this is 15, this is 15, this is 25, and this is 20 mm. That's all. Now this, it has got a hole making in the center. Okay, this is a hole. 5 mm by 15 mm. This is 5 mm, this is 15 mm. That's all. 5 mm, 15 mm, and the hole is through and through. Now coming to another one, this round part, protrusion part, this part is center, make it in center, dia 10, and it is protruding by 5 mm. That's 5 mm. This 5 mm, the diameter is 10, it is bang on the center. That's all. This is for the piston. The connecting rod, very simple. Simple plate. This is 80 mm long, 15 mm thick. 15 mm, 80 by 15 by 5 mm. The thickness is 5 mm, it's just 5 mm. Okay, the entire length is 80. This is 15 and thickness is 5 mm. That's all. And this is hole of dia 10, both are hole dia 10. The center to the edge distance is 10 mm. That's all. From the center to the edge is 10 mm. Same thing here also. From the center to the edge is 10 mm. Okay, you can make it two extrudes. That's all. Now you have crank. This is the crank part. 50 mm length, 15 mm width, thickness is 5 mm. That's all. Okay, and this is the hole and this is the protrusion. This hole of the same size, diameter 10, center to the edge is 10 mm. Similarly, this is protrusion of diameter 10, the protrusion diameter 10, and the center to this edge is 10 mm, and thickness of this protrusion is 5 mm. That's all. Okay, 50 mm long, 50 mm long, 15 mm. This width and thickness is 5 mm. And this holes are both, this hole and protrusion both are 10 mm. From the center to the edge is 10 mm. Similarly, from the center to the edge is 10 mm. This through hole, whereas this is a protrusion of 5 mm. So these are the dimensions of all. I think you should be able to do this. Okay, now I think I have to stop this.